about the expansion of this building. If you look above us up here, there's the ductwork for the exhaust system, how it's just blanked off at this end. So again, for future, they would just continue this way up the hill. Some of the pipes here will end at the end here. Again, for expansion going that way. Downstairs, the steam, the chilled water, blanked off at that end for expansions. Again, I was mentioning the redundancy built into this building, and that was really important being a research facility. When, for instance, if I worked over at Engineering Hall, if we were to take down a piece of equipment, there'd be multiple air handling units serving different areas, there'd be different exhaust fans serving different areas. And what was happening is that we would have to take a piece of equipment down for service. So we would send an email out to everybody in the building saying on this particular day, on this particular time, we're going to be shutting off this equipment. So therefore you can't use the labs, you can't use fume hoods, you can't use anything lab related because we're shutting off the air coming into the building and the exhaust going out so that we could do it safely. Well, once in a while somebody wouldn't read the email or wouldn't get the information, and we would be up on the roof shutting off equipment, and then somebody going through a fume hood and open up a bunch of chemicals and somebody gets sick. Well, it happened a couple of times when over Sohi, somebody opened up a chemical inside of the fume hood, everything was off, and they ended up going over to the DW hospital for a little bit. So they were okay, but it's the potential there that could happen. So the newer buildings, ours included, what happens is we have 4 air handling units. This is one of 4, and they're all connected together with one common ductwork, which is one of them up there. It's a silver wrapped one up there. And so all 4 units serve the entire building all the time. And so consequently what happens is, saying that for an energy aspect of it, all of the fans run at half speed. So if we need to take this one down for service, to prevent a maintenance, or if there's a service issue with it and it shuts off, what will happen is the other 3 will automatically speed up to compensate that. So again, there will never be any kind of lack of air movement, or there won't ever be a time where anybody's going to be inconvenienced in the labs because we have to shut equipment off. So that was one of the big pluses of this particular building. So the other thing that happens is that in Wisconsin we get a little bit of snow once in a while. Sometimes it's that light fluffy snow. And there's buildings on campus such as Microbial Sciences where they took and they put the air handling units again on the roof in the penthouse, but they put the air intakes in the north and the west corners. Well, what happens is when you get that light fluffy blowing in snow, the air handling units suck that in and it accumulates in the air filters, and what happens is when there's enough accumulation, the unit will shut down because you can't get any more air movement. So when we get there in the morning, the first thing we'd have to do is check which units were out, go up there, and sometimes we're shoveling 3 feet of snow out of an air handling unit and changing filters to get them up and running again. So when this building was being designed and going to be built, what they did is they actually took an air intake plenum, which is the door over there is where you see it, and basically it's just a big long tunnel that actually runs the entire length of this building, and the air intake is at the far end. And so what happens is that because of its size, the air velocity is so small that very little snow is ever brought into this building. Okay, so what happens is that the air plenum there is actually built as if it was the outside of the building. It has metal walls, it has metal ceiling, and then the actual floor of it has got a membrane, much like a roof membrane, and then it's got floor drains built into it, much like what you'd have on the roof. So if any snow does come in there, it does accumulate, it'll just melt and go down the drain. So we've never had an issue with snow coming into our air handling units. Another big advantage is of us having our air intake on the 6th or 7th floor is that a lot of buildings on campus, they put the mechanical equipment down in the basement. So therefore what happens is the air intakes are at ground level. So now you've got all the dirt from landscaping and grass clippings and bugs, and you get all the fumes from the cars and the buses out on the streets out above. Weimer, some of their air handling units were put on the basement level. The air intakes were put up by the dock. So what happens is when the trucks come in for deliveries, they have to shut their trucks off, otherwise you get diesel smells going through the building. So again, we're very fortunate here in the way that the building was designed, that we're high enough up that generally that isn't a problem as far as fumes go and dirt. So as the air comes into the building, there's that first section there, and that's a filter section. filters that are there are much like probably you have in your residential home. It's a fiberglass type filter and a cardboard box construction, and that's to get the big stuff, the bugs, the leaves, big dirt particles, things like that. That's the primary or the first part of filtration. The next in line is the reheat, or not the reclaim coil. So I was mentioning that all the air leaving the labs has already been either heated up or cooled down, and so we've already put a lot of energy into it, and now it's going to be leaving the building. So what we have is a reclaim module. We'll see that later. And what the reclaim module does is take that temperature from that air, put it into a glycol solution. The glycol solution is then pumped to the reclaim coils here, so that as the air comes in the winter time, it's already preheated. If it comes in the summertime, it's already pre-cooled. So that does part of the work right off the bat, and we're capturing some of that energy that was being lost. The next section is another filter section. This is a bag filter. This is made out of like a fabric material, and so we can get a much better filtration out of it. Being a lab, we want to have nice clean air going into the lab spaces. This section here is the heating section. This is the 10-pound steam that came from the basement where we were just at. There's a coil in here where the steam goes through to heat up the air in the wintertime. And the next section here is the chilled water coils. That's the chilled water that comes from the basement, 40-45 degrees, and it goes through there to cool the air coming in the summertime and also do some of the dehumidification. And then the last section there is the supply fan, which is what moves the air through the building. And again, the silver insulated ductwork is the supply air, and then the white painted, actually a plastic coating, is the return air of the duct work for the exhaust. It's coated because of the chemicals that come from the labs. Go around the corner.